Section 10.1 deals with something called parametric equations. Sometimes we want to write equations of lines or curves, etc., that really aren't functions. Just to draw a few examples here, it could look something like this. Remember, it's not going to pass the vertical line test. We could be looking at a circle of any size, or something very strange altogether. That might look like this. But here we cannot write the y-coordinate as a function of the x-coordinate. So instead, we're going to let x and y depend on a third variable, and we're going to call it t. We usually use t because of time. So instead, again, we let x and y depend on a third variable, say t. Then x is going to be a function of t, so we could say f of t. And y would be some other function of t. We could call it g of t, where t is called the parameter. And the group of equations are called parametric equations. So as t varies, so do x and y. And this traces as a parametric curve. Let's take a look at our first example. We want to sketch and identify the curve that's defined by the parametric equations x equals t squared and y equals t. So first we're going to create a table. That's how we always learn to graph any function that we've been looking at before, and it's not going to change here. Everything's easier if we just sort of make a table to help us plot points. So I'm just going to include here, we'll have t, we'll have x, and we'll have y. So let's say we maybe just go from -3 to +3 here, counting by ones. And it's important to put the t values in order, because as we go to trace this, we want to know, as t increases, what are the points doing? All right, so let's say we've got -3 for t. X is t squared, so that's going to give us 9, and y is equal to t, so that's going to give us -3. Then we're going to have 4 and -2, and we'll have 1 and -1. We'll just have 0, 0, and we'll have 1 and 1, 4 and 2, and then 9 and 3. So we'll go ahead and plot this. Now again, we're plotting the points x, y, so we want to call the ordered pairs just x and y here. All right, so our first point is 9, -3. Then we have 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, and then 9, 3. It should look familiar. Well, we're going to talk about this in the next part of this problem. But let's kind of trace out the direction. So we want to write an arrow for t as it increases. So we'll just kind of sort of draw an arrow for the direction as t increases. So we started over here at this point, and then as t is increasing, we move to this point. So we're going in this direction. And once we hit up here, now as t increases, we were getting these other points. So those arrows are kind of us tracing out the direction here. So we'll kind of say it this way. So the curve is traced out in this direction. Now on WebAssign, they'll give you the sketches of the graph already, so not only will you have to figure out what the graph is, but you'll also have to indicate the arrows here as well. So making this table is going to be very important. The next part, what we want to do is just create an equation for this curve that we did sketch just using x and y. So we call this eliminating the parameter if possible. So what we have is x is equal to t squared and y is equal to t. So I could simply replace the t with the y. So we just get y, or x is equal to y squared. Or technically, if you did solve this for y, y would equal plus or minus the square root of x. Either version of this is going to graph a sideways parabola. Let's try another one. Let's go ahead and sketch, and then ID the curve given by x is equal to 2 cosine t, y is equal to 2 sine t, for t is greater than or equal to 0 to 2 pi. So when I go to create my table, my lowest value I'm going to choose here is going to be 0. So we'll make t, x, and y. So we'll go 0. Let's go pi over 4, pi over 2, pi. We'll even do 3 pi over 2. And we could even fit 2 pi in here as well. All right, so x again is 2 cosine t. So cosine of 0 is 1. 1 times 2, that's going to give us 2. Y is equal to 2 sine t. So sine of 0 is 0, so it's going to give us a 0. Cosine of pi over 4 is radical 2 over 2 times 2 is just going to give us radical 2. Same thing here, sine of pi over 4 is radical 2 over 2, so times 2 is radical 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 times 2 will give us 2. Cosine of pi is negative 1, so negative 1 times 2 is negative 2. Sine of pi is 0. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1, so we'll get a negative 2 here. And then 2 pi is the same as 0, so we're back to having that 2, 0 there. All right, so again, we want to plot the points x, y. All right, so it looks like we've got 2, 0. We don't really have to be too picky about the radical 2 over 2. Let's next go to 0, 2. We have negative 2, 0, 0, negative 2. So it looks like we're going to have a circle. Let me draw this out a little more consistent here. So it looks like we have a circle with radius 2. So again, let's eliminate the parameter. And what we're keeping in mind is the equation of a circle that has a radius of 2. So we know if it's an equation of a circle, centers at 0, 0, we can say x squared plus y squared. And going back up to what x and y are, x was 2 cosine t, and then y was 2 sine t. So then this becomes 4 cosine squared t plus 4 sine squared t. We could factor a 4 out, and we have cosine squared t plus sine squared t. This part right here is 1. So the equation of the circle center at 0, 0 with a radius of 2 does become x squared plus y squared equals 4. Now let's go ahead and trace this. So again, it looks like we're starting when t is 0, we're at this point here. And then we go to radical 2, which would be up here. And then we're right here, so it looks like we're tracing this way. And then when we're at pi, we're at negative 2, 0. 3 pi over 2, we're at 0, negative 2. And we're going back this way. So that would be how we would draw the arrows on that. Now, for instance, because this was a circle, we could keep going around a few times. We just want to make this note here to be careful. For example, if we had x is equal to 2 cosine t, and y is equal to 2 sine t, but if we were going from 0 to 4 pi, this traces the same curve but goes around twice. So a curve can be defined by several different parameters. Meaning we can have more than one correct answer. take a look at another example. Let's do x is equal to t squared and y is equal to t to the 9th. Again, we'll sketch everything that we were just doing for the two previous examples. Let's make our table first. So we've got t, x, and y. Now again, we want to work with some nice numbers, so I'm actually going to leave some space here, and we're going to just kind of start with the graph and see if we need to go back and talk about any other points. So I'm going to start with -2, then let's go -1, 0, 1, and 2. Now x is nice because it's only t squared, but y is t to the 9th. So x, when t is -2, is going to be +4. And then this is going to become the opposite of 2 to the 9th, because we're raising a negative to an odd power. When t is -1, we're going to get a 1 and a -1. When t is 0, we're going to get both 0. When t is 1, we're going to get 1 and 1. And then when t is 2, we're going to get a 4, and then we're going to get 2 to the 9th. So clearly we're not going to graph the 2 to the 9th here. Let's go ahead and make a coordinate plane. All right, so we can plot the 0, 0. We could plot the 1, -1, the 1, 1. And then clearly if we went over 4, we would be going up quite high. Same thing here. So it looks like we're getting some sort of exponential curve that starts to look like this and then like this. So if you needed to kind of show maybe when it's a 1/2, when t is a 1/2, just to verify the spot here. But this is what our graph is going to look like. And again, as we trace this, we started with 4 and then -2 to the 9th, which would be down here. So it looks like we're moving up this way. And then we hit 0, 0, and then we start to move this way. So that's how our curve traces. And again, let's go ahead and eliminate the parameter. So again, we know x is equal to t squared. And if y is equal to t to the 9th, we could substitute in both ways here. It really doesn't matter. So we could show that t could equal the square root of x. Therefore, y is going to equal, we could say x to the 1/2 to the 9th. So x to the 9/2. Or we could show that t, if we start with this one, is equal to y to the 1/9. So then x is going to equal y to the 1/9 squared, which becomes y to the 2/9. So there's a couple ways to do that.